In this video, let us understand about the application of matrices and determinants. We discussed the application of matrices and determinants for solving the system of linear equations in 2 or 3 variables and for checking their consistency. Consistency. What does this refer to? This refers to a system of equations having a solution. Then what is inconsistency? Inconsistency refers to a system of equations having no solution. Yes. Let us consider the system of equations as a1x plus b1y plus c1z is equal to d1, considered as equation 1. a2x plus b2y plus c2z is equal to d2, and a3x plus b3y plus c3z is equal to d3. Now we are trying to find a generalization for forming the solution. In matrix form, we can write this as a1 b1 c1, a2 b2 c2, a3 b3 c3 in a matrix with x, y, z as the variable matrix equal to the constants d1, d2, d3. So it is of the form ax is equal to b, which implies x is equal to A inverse B. Now the different situations arises. If determinant of A is not equal to 0, then we know that the inverse exists and we find the inverse by the formula x is equal to A inverse B. Now this matrix equation gives a unique solution and is called the matrix method. So using this you can get the solution for x, y, z or the set of equations. Now what is the case 2? If determinant of A is equal to 0, then what do you know? Then the matrix is a singular matrix. So we have already discussed the fact that the inverse does not exist. So two situations arise now. If adjoint of A into B is not equal to 0 and equal to 0. Now even though determinant of A is equal to 0, that does not mean that adjoint of A should be equal to 0, isn't it? So we find adjoint of A into B and check if it is equal to 0 or not equal to 0. Now if it is not equal to 0, then the solution does not exist and is called an inconsistent system of linear equations. What if adjoint of A into B is equal to 0? Again, two situations arise here. The system may be consistent and has infinitely many solutions, or inconsistent and has no solution. So depending upon the situation, you have to decide the solution. So even though adjoint of A into B is equal to 0, there are two options. The system may be consistent and has infinitely many solutions, or it can be inconsistent and may not have a solution.